I've been doing a bit of assembly programming in MPLAB-X IDE recently, and because some of the work that I've been doing has been for the new XC8 assembler, I thought it might be of interest, so I'm going to post some of the things that I've found, give you a little bit of a cross comparison with the old version. Here on the left I've got the old MPLAB-X IDE 5.30. Now that's using the old 32-bit MPASM assembler, and on the right hand side I've got the most, well, it's currently the most recent version of MPLAB-X IDE, that's version 5.45, and that one is only compatible with the 64-bit assembler, so that's the XC8 assembler that I'm using. So broadly these two programs that I've got in each one do the same thing, and I've got the program running on a breadboard at the moment, so I will probably start by introducing you to what is actually happening here, and then we'll have a look at the code, and like I say, we can cross compare. We can have a look at how I used to do it with MPASM and how I now need to do it with the XC8 assembler. Fundamentally it's not hugely different, but structuring the code, particularly the well, in the old we used to use code blocks, in the new we don't. That sort of thing is the thing that probably caused me the most grief. And then also the other issue as well was that I needed to add some linker options in the XC8 assembler version to actually get the code to be placed into the right area of program memory. Okay, anyway, let's just have a quick look at the breadboard then. So you can see the breadboard, it's not going to be hugely complex this. I've got two LEDs here. Ignore this one, that's just my power on indicator, okay? So I've got two LEDs. In fact, let me just power the circuit off and do a power on reset. And you'll see that it starts with this one being constantly on. Now, as you can see here, I've just noted that this is connected to output RB5. And initially, when the program has started, I then turn that port bit high, so the LED goes on, and it's constantly on now, but I'm now in a routine where I'm just constantly polling this switch, waiting for a switch press. When I then press that, then the code is then going to continue, and then it will start flashing, because when it continues, it's then going to enter the main routine loop. So I'll just quickly do that. So now we're in a loop, and let me show you the code. It doesn't matter whether we're looking in the old or the new, because essentially the code is the same, or broadly the same anyway. We've got this main loop here, and we're just turning a pin high, and then we're having a delay, and then turning it low by clearing it, and then having a delay, and then repeating, okay? So there's no further polling of the switch, but what we've done just before we enter that main loop, we've enabled the external interrupt, so now this switch is now working as a trigger for the interrupt. So if I then press this switch, as soon as I press that switch, then we will trigger an interrupt. So then we go into the interrupt service routine, and that interrupt service routine then is going to do something. It's going to turn this LED on. It's going to have a brief pause, and then it's going to go off. So whilst it's in the interrupt service routine, this delay is going to be slightly delayed. The delay will be delayed, if you understand what I mean. So let's just press that switch. Remember, this is going to raise the interrupt, or raise the event. And so that LED came on. Like I said, when this is on, the interrupt service routine is running. Let's just try that again. Of course, it doesn't matter where you are in the code. It doesn't matter whether you're in this delay or wherever, because it's an interrupt. So wherever we are, let's see if we can press that switch while the LED's on. Yeah, so that time worked like that, and let's now press the switch when the LED's off. It still works, okay, as you would expect. So, right, okay, so that's the code. Now let's just have a quick look. Hopefully it's not going to drag on for too much, because I know these videos sometimes I post a long video and I think, oh, that's great because I give so much detail, and then I don't, to be honest, I don't think many people watch them. By the way, if you got this far, please do give the video the thumbs up if you find it useful. You know, hold off for a moment if you want. Add a comment if you've got any questions as well. So let's just go to we're at the top of the source code for both of these programs. As I say, I've tried to keep the coding similar. And so we start off with, in the old version, so in the 32-bit MPASM, we start off with processor specifying the processor as we do in the new version 2. Okay, anything else here is just a comment. And then you're probably familiar that we would normally then include the include file for the particular microcontroller that we're using, which I've done here, but also I've included the XC8-AS include file as well. Now that came about when I generated the configuration bits, and you'll notice configuration bits here look rather different to the configuration bits here. Now, if I'm not mistaken, it's a long while since I've done any C programming, but I think that's more along the lines of C programming style, but I could be wrong, because as I say, it's been some while. Most of the assembly programming I do nowadays is purely for teaching in school. Okay, so how did I get those configuration bits or these configuration bits? Well, it was quite straightforward. I just went on to Window, and I went on to Target Memory Views, configuration bits. And I chose the options that I wanted, for example, the internal oscillator, and reserve those pins for clock, or you can have them for I/O if you want, doesn't matter what you want to do. Okay, watchdog timer off, that's definitely going to be off unless we're handling the watchdog timer, which we're not in my code. Anyway, so you choose the options that you want, and then you click generate source code. And then let's just move this up a little bit. And you'll see that if you copy and paste that, you'll actually be including that xc.inc include file as well. It's important to note that that is included when you generate the bits, but that's not. But that, I think, is essential to the code. Okay. On the other hand, in the old MPLAB-X IDE, if you generate your configuration bits, that also gives you that. Okay. So let's scroll on down. You'll notice that here I've used a C block to declare some symbolic constants. That's the way I like to do it. I prefer that to using equates. However, in the new version, so in the I think it's called XC8-AS assembler, then the C block is out. You can't use it anymore because that's an MPASM directive. And the documentation suggests using a certain or equate or let's just scroll across, or a DS as well. Okay. By the way, everything in this code listing here is what I've typed up. Okay, so it's not a copy and paste from somewhere else. The information, like the fact that the C block is no longer available, that would have come from one of these documents here. I strongly recommend that you have a look at these. Have a look at the datasheet for the microcontroller you're using. Have a look at the XC8 PIC assembly user's guide, and also the migration guide as well, because I found those really useful. Like I say, it's not really a big problem because I think pretty much everyone is familiar with equates, and so remember, they are just declaring symbolic constants. They're not allocating memory. They're just saying that instead of writing 70, hexadecimal 70, you can just write the symbol of 10, which will then be substituted with 70. So not a big deal that we don't have C blocks anymore. The big deal, though, is this one. So hopefully you're familiar with the fact that when you do a power on reset with your microcontroller, the first program address, the first instruction to be loaded will be at the program address of 0. That's known as the reset vector. Now, if you weren't familiar with that, if you open up the datasheet, in fact, shall we do that? So if we open up the datasheet, by the way, you can just control and then you can click on these and then it should open up. So yes, it is. Let's just do that. If you have a look, there should be, well, I know there is somewhere. There we go. You'll see that it tells you that this is the program memory map, and it tells you that the reset vector is at address 0. So you need to include an instruction at that reset vector. If you don't, then your code's probably not going to run. Now, at that particular program memory location, all I've done is include one instruction, because when you look at it, we haven't actually got an awful lot of room there. We've only got from address, well, we got 0, 1, 2, 3 there, because then 4 is the interrupt vector. So we can write like a big program, a load of a big code block here, because we've only got those very limited address locations. Okay. Now, so we have been quite specific in saying that that code block is going to be placed at, or the link, we're telling the linker to place it at address 0. That's my understanding the way it works. But you shouldn't be using the code block. Now, if you have a look in the PIC assembly user's guide, they're very, very specific on, well, they give you a couple of examples and they say that you should be using program sections. Now, I've seen very limited help online. I tried to search for this, and it seems like, I wouldn't say that I'm a trailblazer for this, but there's not a lot of information at the moment for people using XC8 and assembly programming. But I have seen a couple of references where people have done some programming and they are somehow avoiding using program sections, but I don't think that's the way to go. Correct me if you think otherwise, but it looks to me as though program sections, when I look in the documentation, program sections are the thing that they're pushing again and again. So to replace that, what we're now doing is we are doing this, okay? Don't worry about the fact that I've said here, in fact, no, I've also said go to main. So main, by the way, is just a label that we've just set, and main, let's scroll on down. In fact, I don't know whether you know, but if you press control, you can, I think you can, I was going to say that I can control and click. I can in the new version. Apparently I can't control click in the old. Okay, so let's just try that. And that's just going to take me down to the that label, okay? Let's scroll on up. See if we can find that code again. And yeah, so the reset vector is this. Now, initially I found this a little bit confusing because I thought, well, nowhere here, and when I looked through the documentation, I couldn't see anywhere here where we were specifying the actual memory address that we wanted this this very small block of code to be placed. By the way, ignore the fact that I've got a NOP there, a no operation. I must have just been playing around with the code at some point. So yeah, so we've got this reset vector here, but we haven't actually said that we want to place that at this memory location. So it wasn't clear to me actually how that was going to happen. And then initially I thought, well, maybe it's got something to do with resvec being like a reserved keyword or something like that, or maybe the first program section would always be the reset vector. Well, it's not, okay? What you actually have to do, you have to instruct the linker to actually place this program section at address 0, okay? And that was something that really stumped me initially, okay? So let's have a look to see how we do that. So we just click the project properties button. And then, so if you look on down here, you'll see that there is the PIC AS, so that's, as I understand it, the PIC assembler linker. Okay, so we click that. And now I've tried typing them here and I've had them working now. I've also had them working in custom linker options, so that's where I've got them at the moment. And if I just click on this, you'll notice that I've got these two things. I've got -p and then resvect, and I've got -p and intvect, okay? And each one of those, so we've got the name attribute and then we've got a value. So we've got the name and value pair for each one of these with an equals in between. Notice I got 0h, just meaning hexadecimal 0, hexadecimal 0, which is still 0 in any other base anyway, and then 4h as well. Now, so what I'm doing there, I'm telling the linker that the program section with the name of resvect should be, the linker should place it in program memory address 0, and then the interrupt vector, let's just have a quick look at that. The interrupt vector, you can see that's 0, 0004, in other words 4. So the interrupt vector code, which is like there, that code is going to be placed at 4. Okay, let's just move that over to that side for the moment. Let's just cancel out of that. So that's now, because we've used this label, by the way, it comes from that, well, label, not a label, that name, that's where it's picking up the name, okay? So that thing here, that's the name of the program section, it's not this label, okay? Now, the reason why I've got that label there, there was an issue I found that when well, if you have a look at the old style MPASM, you'll see that, and hopefully if you are familiar with doing this, you stick end at the end of your source code, which just tells the assembler that that's it, that's the end of the source code that you want assembled anyway. But when I did the same with this, when I had just end, then I had some warnings. It wasn't an error, it was a warning, it was just raising a warning. And then did some more research, and what I found was that you actually have to, if you want to avoid the warning, then you have to actually say, well, end of, and then you have to give it an address of the start. So basically you're saying, well, look, here's the start earlier, and now here's the end, and then the end of what, okay? So that resvect is now not the name of the program section, it's actually the label, okay? Because remember, or maybe you know this, maybe you don't, but this label is actually going to take on a program address value of wherever this instruction is placed. Hopefully you're keeping up with this. Like I say, if you've got any questions, then feel free to add a comment. Now, so what else we got? So here we've got the interrupt service routine, and here I've just got a little note, and the note is just for my purposes at the moment. I can't really fully explain this, but that apparently program sections, now to me a program section would presumably be for storing only programs, but apparently they can also be used for storing data of some sort. Maybe that's immutable data, I'm not too sure. But apparently you can use program sections for data, and so this microcontroller, which is the PIC16F627, has it's one of, I think they're called the baseline device. In fact, yeah, I see it there. Okay, the baseline device, and so what that means is that its data words are 8 bits in width, and so if you want to actually have a program section for data, then you need to set the delta flag to be 1, and the program code, so if you do a program section for code and you're doing it on the PIC16F627 or another baseline device which uses a 14-bit wide word for the program instructions, then you need to say delta equals 2. I think I've read in the documentation somewhere that actually the default value of delta is 1, so if you omitted it, it wouldn't be a problem here, but you would need to check that yourself. Also, and I don't normally use them, the PIC18F I think actually has a program instruction opcodes that are only 8 bits wide, so that would be delta 1 as well. Once again, do confirm that yourself. Okay, so the next thing then is the program section for my interrupt service routine. So once again, I use PSECT as the directive, and I give it a name. You can give it any name you like. I'm sure there's some sort of naming rules, but you know, more or less what you like. We say that it's code, and then delta equals 2. For the reason I said before, because we need to use 2 bytes per program instruction because we're using 14 bits. Okay, so then I've got my code, and things are slightly different here, and this one did catch me out. So let's just, if we say compare this line with this line, you'll notice that when I was programming previously with MPASM, that when I did a bit test file skip if set, then I would then specify first of all the file and then the bit within the file, and they were comma separated. Let's just have a quick look at the instruction set summary. So let's, I'm sorry if this makes it a little bit slower, but I think it's worthwhile. So we go to the instruction set summary, page 107, and you'll see that for many instructions, like say bit test file skip if set, so bit test file skip if set, you'll see that it takes there we go. So we've got the operator and the operand. It's got 2 things there. Okay, it's got the file and it's also got the bit, which is what I was doing there. I've got the file and then I've got the bit. But then maybe you're then wondering, well, why then, if I'm using the same microcontroller with the same instruction set, why am I not doing the same? This did catch me out for a while until what I realized was if I checked the include file, that the include file is different. And when you do something like, let's see if I can find it again, I've lost track of where we were. Okay, when we do something like that, the include file is actually going to, or rather the assembler is actually going to substitute the something different for that. So if I type int f, it's not going to just be interpreted, or rather assembled as just being one thing. It's actually going to be a file and a bit. Okay, now I think the only way we're actually going to figure that out really is if we actually have a look at the assembly file. So I've got myself a link here just so we can open it up hopefully fairly easily. And so let's now search for pick 16F627 Inc. And we've got the 627 and the 627A, I think it's that one. And so what we were talking about, let's scroll on down and scroll left a little bit. So it was like, for example, int f. Okay, so let's just see if we can do a search for int f. And we scroll on down. Now this, I don't know whether you're much familiar with looking through the include files, but this is actually quite a bit different from how it used to be. And in fact, what we should do is just find the next. And you'll see here that when we reference that symbol of int f, actually it's going to be more than just the, say, the bit number. Now it's actually using this bankmask. Presumably bankmask is a directive, bankmask int con, and then the bit number. Okay, so actually what we've got there, we've got two things in one. So even though I've got just one thing there, it's actually going to be substituted with two. Okay, now I can't really give you a lot more information about bankmask. I've tried to find a bit of information, and the only thing I could find is that people don't like it, but I'm sure there's more to it than that. Okay, so just for the moment though, that's the only way that we can actually get this compiled, or assembled rather. So otherwise, apart from that, things are more or less the same as they were before. If you want to have a quick look at my code anyway, so what am I doing? First of all, I'm just checking what interrupt was raised. Then I'm saving the program context, doing something with the LEDs, and then restoring the context, and then returning from the interrupt. Okay, so nothing much different from how you would have done it in MPASM. Then I've got some delay routines here, and so we've got delay routines here. I think you would need to, oh actually there is something that's going to be worthwhile mentioning here. Here I've just said use a code block, and I didn't provide an address this time because I'm quite happy for the linker to place it wherever, and like these code blocks they had to be placed at address 0 and had to be placed at address 4. This code block can be placed wherever, and the same for this one actually. So this program section can be placed wherever, so I can just say program section code. Okay, don't even need to give it a name actually now. Where did I find that? I think that was probably in the XC assembler users guide. I've got a feeling that I've read somewhere, or maybe I've found, that if you don't include the colon after the label, then it won't assemble, but you might want to just check that. Maybe I'm dreaming that one up. Scrolling on down, let's have a look, see what else we can find. Yeah, there is something actually that is going to be relevant. That previously, I don't know whether you were specifying binary numbers using that format, which I sometimes use. So move a literal into working file register with a binary value, and then in single quotes, then I've got that binary bit pattern. Can't do that anymore. Okay, so the XC8 assembler doesn't allow you to do that. If you want to use a binary number, then you need to do it in this fashion with the suffix of that. I think it has to be a capital B, but I'm not too sure, but it certainly has to be a suffix of B. Okay, so that one is another little thing that caught me out. Also, I think the default radix is now binary decimal unless you specify otherwise, but once again you might want to just double check on that. Anything else? I think that's pretty much it now. Okay, so hopefully that's given you a bit of an idea as to how it's not really too difficult actually if you've used MPASM to now get your code in an XC8 compatible version, but it's not maybe, I mean this is a trivial example. If you had a more complex example of libraries, I just think that's going to be a big job. However, I'm just a teacher, and I do a little bit of programming in assembly, and yeah, we program some slightly more complex programs in this, but in truth, most of them are relatively simple. But hopefully it's helped someone. If it did help you, do please subscribe. I can, if there's interest in these videos, then I will produce more videos. Okay, so, and I see that through the subscriptions and also your comments, even if it's just thanks or just point out my coding mistakes, I'm quite happy to take that on too. Okay, thanks very much for watching.